technical fellow, the highest technical level at Microsoft, working in the Windows Core Operating System division. I often get asked, what do technical fellows do at Microsoft? And basically whatever the hell we want to, which is kind of nice. So it lets me do things like write the book and come here and speak and write the book that just came out. So here's the outline of what we're going to cover today in this troubleshooting talk. This, if you didn't catch it from the name, normally it's called the Case of the Unexplained Advanced Windows Troubleshooting. They left that part off, so the Case of the Unexplained is really ambiguous. It could actually be, real-world detective stuff, I guess, if you wanted to interpret it that way. This is really about troubleshooting Windows, and I've divided the walkthrough of different scenarios into a few different topics, as you can see there. First, I'm going to set the stage for what exactly I'm talking about here and around what I want you to take away from this if I do my job. Then I'll take you through real-world examples, sluggish performance, application hangs, troubleshooting error messages, what happens when an app crashes, how do you figure out what's going on there, who's the fault, and then finally a little brief dip into blue screens. How many people were in the crash analysis talk that Dave Solomon just gave? So this is going to be a review for you guys, and for the rest of you, it's just a quick dip of your toe into that area, just so you can have an idea to very quickly be able to take a look at crash dumps. How many people have been to the Case of the Unexplained previously, a previous delivery? So almost everybody, and I'm glad that you came back because this is full of entirely new examples. In fact, I have been collecting examples. As you know, at the end of them, I say, if you've got a real-world case, get the log files, get me the crash dumps, send them in, then I can have something to draw on and share with other people the way you troubleshot it, and I'll send you back a signed copy of the Windows Internals book. And actually, I was thinking of cutting this off because if you look, that's weird. I'm seeing something different than you are. Oh, yeah, it's probably, it was working before. There, extend. All right. Well, I am extending it. I don't even know what that's doing. Oh, look at that. Oh, duplicate. Yeah, sorry. It is Friday afternoon after all. All right, and I'm hungover. So I was mentioning that I've had people send them in. This is the full deck that I have to draw on. You can see if you look down here, there's 239 slides, and it's growing. I just got another 2 today to add to it. So I was actually thinking of cutting off that offer. But if think you've got a real good one, then make a case for it, and I'll send you a signed copy of the book. So as far as setting expectations here, most of you have had to run into problems on Windows. Hopefully very rarely. How many people have run into some kind of problem within, say, the last month? Okay, that's just about everybody. Maybe ask it the other way. How many people haven't run into a problem in the last month? 1, 2. Good for you. So the reason that you run into those problems is out in the real world of your systems, the software that people write run into situations that they weren't written to expect. And that is what causes all sorts of misbehavior. Because application developers write for the case that they expect. When they end up going down a path that they didn't expect, they didn't test that path most likely. And you end up with things like weird error messages or crashes. And the things that cause them to go down those paths include everything from ACLs being set weird on a file that they always expect to be able to read, to some app corrupting their registry data, to a DLL being missing because something uninstalled it. Any number of problems, and you're going to see a bunch of examples of those kinds of things in this session. I'm not here to give you the recipe. I'm not here to give you the, hey, if you run into a problem, follow this checklist. 1, do this. 2, do this. 3, do this. 4, you've got the answer. Because that's just not the way it works. I wish it did, and I've been working for a long time to try to figure out a way to make it more like 1, 2, 3, 4. But it's just the diversity, the number of inputs, the number of variables make it so that every case is different and requires a little bit of imagination on your part to go figure out the right way to get clues to figure it out. So that's what I'm here to do, is to teach you how to understand the way the system's operating. So I'm going to tell you how to interpret file and system and registry activity. I'm going to show you how to interpret a call stack, which is one of the most powerful tools when it comes to troubleshooting. And I'm also going to give you a tour of the tools and some of their capabilities so that when you do run into a problem, you can leverage the tools in maybe different ways than you're going to see me leverage them in this session, just because you're aware, hey, I know that tool can do this, and this other one can do that, so maybe if I combine the two, I can get some idea about what's going on here. So the idea, again, is giving you the tools and information so that you can go and figure out how to troubleshoot problems when you run into them. And the tools we're going to use here, not surprisingly, a bunch of are from Sysinternals. Sysinternals is an awesome website, some of the best tools ever written, I think, on that website. So Process Explorer, Process Monitor, Autorun, SigCheck, we're going to see all of these in this session. And then for those of you, by the way, has anybody not been to Sysinternals ever? Nobody? One. Okay, you're excused. Then there's some Microsoft downloads I'm going to show one of them in this session. It's debugging tools for Windows. If you go back and look at the previous two CASOs, both of them are posted on Mark's webcast site page on the Sysinternals website. You're going to see me use in those other ones another tool called KernRate and another one, Visual Studio Spy++, to solve other cases. I won't be showing them in this session. I just wanted to make you aware of those tools and their use for troubleshooting. Let's start with the real-world case now. Sluggish performance. So sluggish performance is application seems to respond sluggishly. In this case, a user would see a CPU burst in their tray, and Outlook would hang for 15 seconds whenever they received an attachment. And I know what you're thinking. Outlook hangs for you for 15 seconds all the time. So what's the big deal here? Well, this person actually had pretty reasonable performance with Outlook, so this was unusual. And of course, the question is, why is this happening, these 15-second delays whenever they just happen to get an attachment? So what they turn to is Process Monitor. Now, Process Monitor, here's a slide that describes its basic capabilities. I'm going to switch over to the demo machine and show you Process Monitor running live and walk you through some of the features that it's got. So Process Monitor, when you launch it, if you're familiar with FileMon and Regmon, this is FileMon and Regmon combined with a whole lot more capability and a whole lot more scalability and a lot richer editing or filtering capabilities. The default columns it shows you, the timestamp, and the timestamp, as you're going to see in one of these cases, is very useful to identify points in a trace where you might have a delay. This next column is the process that's making an operation with a tooltip that shows you where exactly that executable is and shows you some information about it, pulled from its version information, which includes its description and the company that produced it. The next column is the process ID. The next is the operation itself, what this process is doing. Here it's querying a registry key. This is the registry key. It's querying HKey local machine. And then over here on the result, it tells you whether it's successful or whether there's an error. And then finally, in the details, it will show you additional information about that particular operation. In the case of a query, it's querying the handle tags, and the handle tags value that it got back was 0. That's not particularly interesting. If you look at a reg binary, it'll actually show you the data in the binary file and the binary registry value. For directory or for enumerations, it will show you the name of the registry that came back. So a whole lot of information here stored in the details. This isn't the only columns that you can present, and there's a lot of information captured for each individual operation, which could be useful, that's just not shown by default. You can get to that with the select columns here and add different fields or types of information that are grouped into their categories here. Application details. So this is information about the process as it was launched. So the process name, the image path. You could add the description, the version number, the company name. The command line is often useful to understand what's going on with the process. Very quick look at that in the main view. The event details. So event class, date and time, category, whether it's a read or write. We'll talk about that later. The relative time, the duration of a particular call. So if a file system call took a really long time, you would see that as a very big duration in the duration column. And then finally, process management. If you've got a terminal server system and you're debugging something that happens in one user's session versus others, then you can add the username column and filter based on the username or the terminal server session ID here. There's also the thread ID if you're looking at a process that has multiple threads and you're interested in which particular thread's causing a problem. So a whole bunch of things that you can add there as additional columns. Also, if you double-click, there's all that information is presented for each operation here in the event properties dialog. So the thread, the class, the operation, the result shown here. So you don't necessarily have to add these things as columns. They're always accessible to you. Here's, for example, more information about that service host process we were looking at, its parent process ID, what account it's running in, whether it's 32-bit or 64-bit, because I'm running 64-bit Windows here. Its Windows integrity level. If you went to Manasseh's talk, you know about what that is. And then the list of DLLs loaded into that process at the time of that operation. So if this process loaded another DLL a few operations later, it wouldn't be reflected in this list. This is at that point in time. And then the last tab is the stack tab, and we're going to look at that a little bit later. So that's a basic tour of just the information views. I'm going to touch on some of the other capabilities as we go through here. But let's get back to that troubleshooting case that I was just mentioning, this guy with this Outlook hanging for 15 seconds when he'd get a file with an attachment in it. So he fires up Process Monitor. Let's open that log file and take a look at what he saw. Oh, here's something you might see if you're running 64-bit Windows, because by default, Process Monitor is launching a 64-bit instance of itself. To look at a 32-bit log file, you need to launch the 32-bit version of Process Monitor. The way Process Monitor works on 64-bit is the 32-bit version launches, says, oh, this 64-bit system extracts from inside of it, kind of like an alien thing, the 64-bit version, which is then running. And you can run the 32-bit as it says there with the command line option. So let's go do that so we can look at that log file. So here's the 32-bit version. Now we go look at that log file and read its contents in. So when you get a log file like this, first thing you do is kind of scroll through to see if you see anything unusual. You see anything unusual? Anything? Anybody? Nothing? Actually, it's pretty obvious what's going on here. There's something that's just hammering a particular file over and over again. You know, the first time I saw it, I thought it was SCWTF, which I thought would be more appropriate than RTF. There's another way that you can, if you've got a big trace with a whole bunch of stuff going on and you think that there's particular activity against a certain registry key or file, there's tools up here which will do, for example, a file summary, which will show you which files were accessed the most. And here's that file that we saw there, here. And if you take a look at the number of operations against it in this trace, there's 133,000. So there is a lot of stuff happening. There was only one open and 133,000 writes. That's what you would see there out of the total of 140,000. So some tools up here. I'm going to show you a couple of other ones as we go along, but just be aware of them. Automatic ways to mine the data if you're interested in that kind of thing. So what's the next step here? He sees this activity going to this particular file, scwf install rtf. He has no idea what that could be. And it says there's one clue, that directory that it's writing it to, which is in the temp directory with a subdirectory called escan. So his next step was to go figure out what escan might be related to. And he searched the web for it. And with the wrong search engine. It happened to find a link of use. And it's telling him that he opened that link up, and that's a forum on the McAfee help website where some users are complaining about the same thing, and they're basically saying it's this particular version of McAfee with a particular setting, which is scanning for on-delivery email. If you look, the directions in the forum actually tells as a workaround to go into the VirusScan console settings, which you can see there, and to disable that. And he went and looked. Sure enough, it's enabled. He disabled it, sent himself a big attachment, and the problem was gone. So case closed with the use of Process Monitor. Wrong thing. Let's go back to the deck. This next case is going to involve Process Explorer. So I'm going to stop here and give you a brief tutorial or run through of Process Explorer. Process Explorer, as most of you know, is a task manager replacement. A lot of people call it Task Manager on steroids. In fact, you can actually use it to replace Task Manager. Let's go see that in action. And if you haven't replaced Task Manager with Process Explorer, you need to go do that immediately. It's with this checkbox right here, Replace Task Manager. And I have it unchecked just so I could show you checking it. Whoop, bug in Windows 7. You didn't see that, did you? Okay. Now, one of the things that I always do this. I configure Process Explorer to start when I log in. And I configure it with the /E switch in my startup folder with a shortcut. /E says elevate, so I'm running it with full admin rights if I'm running with the UAC on. And then with the /M switch, which causes it to minimize into the tray automatically. So I get the prompt every time I log in, I say yes, and it minimizes into the tray. And since I don't boot or log in that often, it's not that big of a deal. And what I get for it in return is Process Explorer ready to go and troubleshoot any problem, even if it's a system problem, right from the tray. And the tray shows me a brief history of process activity, so I can see if something's running away with the CPU. I can see that as red or green in the tray and go start investigating what's consuming my system. In many cases, it's not noticeable, really. As you're using the system, especially if you've got a multi-core system, one CPU pegs to 100% because somebody's run away with it, and you're still able to use the system, maybe even without noticing that because of the other cores. But if you're running on a laptop, for example, that thing burning a CPU is going to kill your battery life. So even if you can get your work done and you don't seem to notice it, it's still important to go troubleshoot those things. Let's go take a look now at Process Explorer. And when you launch it, you're going to see this tree view, which is obviously very different than the flat list you see in Task Manager. You also get more information displayed for you automatically, like the name of the process with a tooltip, like you saw in Process Monitor, showing you, for example, the path to the executable. For hosting processes, you're going to see the things hosted inside of that. This is a service hosting process, so you're going to see the names of the services running inside of that process. Then you see the process ID column, the CPU column, the description and company name, kind of like you saw in Process Monitor. For a particular process, though, you can see lots more information here in the process properties. You can also add a whole bunch of this stuff as columns. So again, information about the image, information about the process, who ran it, what time it started can be useful for troubleshooting, whether it's 64-bit or 32-bit. And these other tabs, process-specific performance. So if you've got something, hey, maybe this thing is running out of address space. Maybe it's got a memory leak, which would be reflected as a big private bytes value. Or if it's doing a lot of I/O, you would see that over here. And then a performance graph, which is like the Task Manager system-wide performance graph, just targeted at this particular executable. The services, like I mentioned, running inside of it. The Threads tab I'll show you in a second. The TCP/IP tab up here would show you any open TCP/IP endpoints. The Security tab would show you the list of groups that this thing belongs to, the security identifiers, so on. So more advanced stuff than I'm going to be able to get into today. Environment variables, which can be used for path lookups, for example. That's the most common way that an environment variable can screw up an application's behavior, is if the path is misconfigured and it ends up pulling a DLL from someplace other than where it expects to find the DLL. I've seen that many times. And then finally, Strings tab. I'm going to have an example later where I'm going to show you troubleshooting a piece of malware, but in Strings tab, that's what it's aimed at, troubleshooting malware or figuring out something that you can't identify in any other way, what it might be, because the strings inside of it might have clues, like paths to registry files that have a vendor or product name in them, or strings that relate to the internal debug messages that might give away what it's for. So let's go on to the next case here. And this was one that I experienced myself. It's before I joined Microsoft, obviously. I was using this other virtualization tool. Actually, I was using it before Virtual PC could support or Hyper-V, Microsoft had support for 64-bit guests on 32-bit VMs, and I was still running 32-bit OSs a lot, so I had to use this. And also before snapshot trees were made available in Hyper-V. So now I, of course, use Hyper-V. It's way better. So anyway, I was running VMware, and I noticed a CPU peg every 10 seconds, and the desktop would freeze. And how many people have seen that? You're moving the mouse, and bam, the mouse freezes, then it goes, then freeze, then go. Yeah, it's a common thing. And I was running into that, and after a few hours, that got really annoying. So I decided to investigate it. So actually, no, after a few seconds, it got really annoying. And so I decided to take a look. And first thing is to go into the system information graph and take a look at what's going on. And this is how you get to that. You can get to that in a few ways. You can right-click and say System Information. This will show you a history of the global system activity with a lot of information down here about total number of handles, total number of threads, commit charge, a bunch of the things that you see in Task Manager's system dialog, system performance dialog, physical memory usage, paging list, paging rates, and I/O rates. This is what I find most useful up here at the top, is this graph, which shows you, when you move it over a particular point, it will show you the process that was consuming on your system the most CPU at that point in time, how much CPU it was consuming, and that timestamp. So that's what I leveraged over here. I moved the tooltip because obviously with the mouse frozen, I couldn't actually go and see what was going on. I had to rely on this history here. So to actually go and figure out what was at the spikes, which process was causing those spikes. And you can see it's the system process there. So the system process, what was I supposed to do with that? The system process is a process that is also a hosting process. It hosts device driver threads and kernel threads. So every process consists of at least one thread. A process is just a container, and it has some information associated with it, like who it's associated with, what handles it's got open. So resource accounting is done for it. So when the process exits, then all the handles get automatically cleaned up. It's also got an address space. But the stuff that actually executes code, those are threads. So every process needs at least one thread to get anything done. Most have multiple threads because most have UIs or have background activity going on inside of them. So they will have one thread for UI, for example, and one thread to do stuff in the background. If they only had one thread, then the UI would become unresponsive when it would go and have to do work on your behalf when you click something. Like I said, the system process is the default home for kernel mode system threads. I also mentioned that back when we looked at service host, that was a hosting process for services, and those also execute as threads inside the service host. There's also potentially pools of generic worker threads, both in the system process and the service host process that you will see, that really are for use by any of the other threads in that process, where they can just feed those threads work and not have to hang around and do stuff, wait for things. So they just dump things to these worker guys. It's kind of nice to have people to do things on your behalf, isn't it, without you having to do it. Other hosting processes, Internet Explorer is a hosting process. Hosts lots of third-party plugins that might have their own threads. MMC is a hosting process. DLL host is the out-of-process COM object hosting process. So that's going to be hosting COM objects. Like you saw for service host, any of these, well, service host, MMC, DLL host, and Run DLL32 is another one. You will see in the Process Explorer tooltip what's hosted inside that process. So I mentioned threads, and how do we dig into threads? Now that we saw that in that one case that I had, something in the system process consuming CPU, what the heck is it? I needed to look inside that process and look at the threads. And Process Explorer lets you dig into the threads. Let's go take a look at something that creates threads, and I'll show you that Process Monitor or Process Explorer actually will show you not just which threads are running, but highlight threads as they come and go, which makes it easy to see if somebody's creating a lot of threads or recreating a bunch of threads. So this is CPU stress. We're looking at the threads running inside of it. There's one thread here that seems to be doing something, because then that one would correspond to this right here, where you can select the checkbox that causes CPU stress to create a thread that just does some CPU activity. And you can specify the level of activity. If I deselect that, that thread goes away. if I check it back, you're going to see green showing a new thread, and then that goes away. Then you're going to see cycles delta. So obviously the thread that was left there, that is this GUI thread. And if I move that around, then we cause cycles delta for it because it's got to redraw itself. So let's now go take a look at how I looked at the threads inside that system process to see what was going on there. What I did, so I opened up the system process and I looked at the list of threads inside of it, and this is what I saw at the very top. And one of the, so you can see CPU usage there. The top thread in CPU usage began its life in http.sys. So as you saw when we looked at the threads tab and just now for CPU stress, it showed you which module that thread began its life in, CPU stress, because that's the process we were looking at. In this case, it will show you the birthplace of the threads running in the system process, which will reflect where they actually came from, what driver or system component. So http.sys is the in-kernel web server in Windows, built into Windows. So being a Windows component, I didn't suspect that as probably being the real cause of my little mouse hangs. So I looked at the next one down at 11%, and it was ftser2k.sys, which I had no idea what that was. I took a look at the file properties for it, and I found out that it was the XM Radio USB serial driver. I was using XM Radio with one of those USB things back before they started streaming over the web. And it looked like this was causing the problem, might be indirectly causing the problem. So I stopped it by going into the Service Control Manager and doing a net stop http.serve or ft2k.ser to see if that was the problem. The problem didn't go away. So then my next step was to go stop that in-kernel web server. And I stopped that. It warned me about dependencies on other services, which I didn't care about because I wasn't hosting a web server on my system. And then the problem did go away. So I'd kind of got rid of the problem. Now, did I solve the case? No. Did I care that I didn't solve the case? Not really. And that's one of the other learnings that I hope you take away from here is that troubleshooting, successful troubleshooting doesn't always mean finding the real reason for a problem. In fact, it might take hours or months or way more experience or domain-specific knowledge to be able to figure out exactly why that's happening than any of us want to invest in. Many cases, successful troubleshooting is finding kind of the root cause and a workaround. And what I'd done was find a workaround here, which I was happy with. You know, at some point later, I might have run into something that needed http.sys, and I would have had to go back and figure out what to do about that. But for my situation, I never had to, and as far as I was concerned, the case was closed. This one is one where, again, the tooltip gave me a clue what was going on one day. I was sitting there using my computer. All of a sudden, it seemed kind of out of the blue. Because you know when you're using your system, you're not paying attention to really all the things you're doing. You just kind of walk through things. And at some point, I noticed the tray icon was half green. This is a two-way system, so it means one of my cores was fully pegged. I moved the mouse over it, and it's Internet Explorer. So what was going on? You know what? I took a look at my desktop, and I didn't even have Internet Explorer visible. I'd exited it a while back. And so what the heck is Internet Explorer doing still alive and consuming my CPU? This is a case where I could have just killed Internet Explorer, and the problem might have completely gone away, and I would have been fine. That would have been a fine workaround. But one of the reasons that I chose to investigate it, and I suggest you do it too, is that what if the problem came back? I mean, it'd be best just to, while we've got it here, go figure out what's going on so that if it is a problem that's going to persist, I have taken care of it. I'm not going to be affected by this again. So for that reason, I went and started to troubleshoot. First thing I did, of course, was open the Threads tab for Internet Explorer to look at what threads were consuming CPU. And this is what I saw. msvcrt.dll. And that doesn't tell me a whole lot, because msvcrt.dll is basically a generic system component. It's part of the Visual C runtime, or the C runtime that's built into Windows. So a thread had started here, but it was doing something. It had called into something else, and to figure out what was going on here, I needed to figure out what that thread was executing right now, not just where it began its life. It required deeper investigation. So for that, I had to turn to the thread stack information. So let's talk about what a stack is. A call stack is essentially a record of the function invocations performed by a thread at any point in time. It's history since it began its life. The very top of the stack is where it began its life. So that would be function 1. That would be that MSVCRT function that we saw. That function at some point called another subroutine, maybe in its own code or maybe in another DLL's code. So that next function is going to be pushed onto the stack, and so on. And when function 3 there finishes, the system knows how to continue execution in function 2 after the point that function 3 was called, because that information is stored on the stack. So it really, the stack serves as this temporary per-thread region of memory where the functions that are executed by that thread can pass arguments to each other, store local parameters, and also figure out how to get back to where they came from. And that's, like I said, this is the heart of advanced troubleshooting, is leveraging the stack, which I had to do, obviously, in this case. So how do you look at the call stacks? Process Explorer lets you look at the call stacks for threads from the Threads tab. If I go look at Internet Explorer, or Explorer here, and I double-click, I get a stack for it. Now, what's happening here with this delay is I've configured Process Explorer to pull symbol information from the Internet. And there we go. That's also something that's very valuable is to configure Process Explorer and Process Monitor to pull symbol information for the Windows components directly from Microsoft symbol servers, which are online and accessible from anywhere. And the way that you do that is to go to the symbol configuration option dialog. Actually, I've got to close that out and come over here to configure symbols. And this is an internal build of Windows 7, so the public symbols aren't available online yet. Sorry, it's not an internal build. This is the RC that I'm running. The symbols haven't been posted yet because those guys kind of take their time at posting the symbols for some reason. I bothered them this morning to say, hey, get your butts in gear, post the symbols so that we can do things like this. You also need to point it at the debugging tools for Windows DLL if you really want to maximize the use of the symbol server. That's that free download that I referenced on one of the early slides. Just go to Microsoft's website to download the debugging tools for Windows. It creates a directory, and just point this at dbghelp.dll. In fact, if you download that first and then run Process Explorer, it will go find it itself and populate this, so you don't have to do it. So once you've done that, then you can get addresses of functions that might give you some idea of what's going on. So this is a wait for multiple objects that it's doing there at this point in time, because inside the NTDLL file, because I've got symbols pulled down for NTDLL, so I know what function on the stack that corresponds to. Let's go take a look at what I ran into when I looked at the stack for the IE thread. I saw this, gp.ocx, all over the stack. Of course, I didn't have any idea what gp.ocx. There's no symbols for it, giving me the hint that this is a third-party component. It's not built into Windows, otherwise I would have seen symbol information for it. So I open the DLL view. Let's talk about the DLL view. Process Explorer has this upper pane, which is the default view, full process list. For any particular process, you can click on it and then open up the bottom here to look at what DLLs are loaded into it. So I've opened DLL view. Not just DLLs, though. This is any mapped file, which can be a data file that is mapped into the memory of that, the address space of that process, so it can access that data as if it were just part of its memory, instead of having to do read file and write file system commands on it. And just like for the process view, you see information about who made the DLL and the version of the DLL. And there's other columns you can add that might be useful for other types of troubleshooting, like how big the mapping of that DLL is in memory, how much how much of the process's in physical memory footprint is consumed by that particular DLL, whether it's 64-bit or 32-bit, whether it's signed by a trusted publisher, and so on. What I found when I looked at the DLL view for this, I saw gp.ocx, get plus R, so registered trademark, just so you know, ActiveX control. What is this thing? I had no idea. From NOS Microsystems. Anybody heard of NOS Microsystems? So at this, neither had I. And at this point, my heart started beating a little faster. It's never good to find some unknown piece of software lurking inside of Internet Explorer on your system like this. And I did a search online. This is a feature built into Process Explorer where you can right-click and say Search Online. And it uses the correct web search engine by default. Actually, it uses whatever that you've configured to search online. So it used to just use another web server, another search engine before I came to Microsoft and figured out, the right one. So NOS Microsystems. Nothing online. So at this point, I'm really getting concerned. This looks like a real piece of malware. So I searched for NOS Microsystems. I went to, on the web, you can see over there in the search box, NOS Microsystems. And what I found was this web page right here, which says, welcome to NOS Microsystems. Our product Get Plus and NOS installer are cutting-edge technologies. That's what it says here. So this obviously looks like somebody that licenses some kind of installer technologies. And then, bing, a bell went off. About an hour earlier, I had gotten one of those fairly annoying Adobe Acrobat updates are ready for you that you get about once a week, right? And so I'd gone to the website and downloaded Acrobat. And this is kind of interesting because me having run into a real piece of malware at some point in the past that you might have heard of, I considered myself very careful about looking for suspicious things on the web. And when I saw this, I was a little bit embarrassed with myself, a little bit ashamed of myself, because I went back. The only way that I could have gotten this on my system is if I'd gone to the Adobe Acrobat update page. It presented a yellow bar that said, click here to install an ActiveX control from NOS Microsystems, and I had just done that without looking twice. That's the only way this could have come down here. So, now, what I should have done is gone, Adobe Acrobat update, but it's asking me to download this ActiveX control from somebody I've never heard of. I would have gone and investigated what was going on there before just clicking on the yellow bar and saying, OK. But obviously, I hadn't. And fortunately, this wasn't the real piece of malware, but I had figured out what was causing IE to go into an infinite loop there. So lesson learned there. Always look at the gold bar. And now, by the way, Adobe uses their own installer. So I've paid attention now. The next times I've gotten Adobe Acrobat updates, they've got their own. So let's talk about hangs. Now, this one is one of my favorite cases, because this one highlights a way that somebody can use the tools in ways that maybe I don't expect to find interesting solutions to problems, and where those problems are really affecting their organization in a major way. Multiple users started complaining to this enterprise admin that logon would take 3 minutes, where they pulled the other users and their logons were normal speed. They'd started to do an investigation. Every user that complained, they went and did an inventory of what software and what hardware they had. And the same thing for the users that didn't seem to be experiencing any problems. So this is over the course of a couple days. They're doing this investigation to collect all this data. They start comparing it, and they find one common theme. The users that are complaining have Dell Precision 670 workstations. All of them. And none of the users that are complaining have those workstations. But yet there are some people with those workstations that are not experiencing the problem. So it's only a subset of those Dell machines that are showing this problem. So the user configured Process Explorer to run during the logon sequence, which is as easy as just putting in your startup folder or run key. And when they logged on one of these problematic machines and they saw this Lisa client application consuming CPU, the network administrator, of course, knew immediately what this was. This was the in-house asset inventory software that they'd created that runs on logon, does an inventory of the system, sends it off to a master database so they can keep track of what's going on their networks. After that big burst of CPU activity, the Lisa client would go idle for several minutes, and then it would exit and the system would continue acting normally. So the question is, what is that Lisa client doing? For that, they turned to Process Monitor. And they captured a trace from a good Dell system and one that wasn't running well, and took a look at what was going on. So the first thing they did was took a trace from one of the systems that wasn't running well. And this is where I told you the time of day can be useful, because remember that hang that we're experiencing was 3 minutes. So there's a lot of data in here that this Lisa client is doing. So the question is, what is interesting here? Because there's lots of results that are actually errors. And so this looks like finding a needle in a haystack. Which of these things is causing this problem? Well, the answer is in the timestamps. If you go back and look, the first timestamp here is 1241. And 1241, 1240, oh, suddenly there's a jump right here from 1241 to 1244. 3 minutes, exactly corresponding to how long their logon delays were. So what is that operation that's taking 3 minutes? It's an ioctyl SCSI pass-through command. And it's getting back this error, IO device error, which happens to be the only instance of this type of error in the trace. So there's a whole bunch of errors, but only one IO device error. So obviously this ioctyl SCSI pass-through command is causing a problem, but what's going on under those other Dell systems that aren't having the problem? Let's go take a look there. And to find this, what they noticed in that previous trace is that the command immediately after that SCSI pass-through was this one, because there's lots of SCSI pass-throughs in the trace, but the one immediately after that problematic one was the only smart drive query in the trace. So that means that the one that they were interested in is this one right before it. So they go look, and it's a device out of control SCSI pass-through, but on these other systems, there was a success. So, well, okay, what's the difference now between the disks on those systems? So they go take a look at the disks, and they found that the working systems all had Fujitsu disks, and the ones with the problem all had Seagate drives. So obviously this pass-through is causing a problem on these particular versions of these hard disks. How do you fix this? Go replace all the drives. No, that's not a good answer. The answer is to try to work around that problem, try to make sure that Lisa client isn't issuing that SCSI pass-through command. So this is an in-house application. So of course it was written by in-house developers. So the IT Pro people submit a ticket to their in-house development people saying, hey, we've got this problem on our network, and well, you know the drill. It's like, okay, thank you for your input. We should have something out ready for you within 90 days. So at this point, they're left with, how do we get our systems up and running smoothly? So what they do is write a WMI script, which would go as part of the logon process, detect the disk type, and if it was a problematic disk, skip the Lisa client altogether. That was the only thing they could do while they waited for those developers to fix the code so that it wouldn't issue that command. Case closed. Error messages are probably the most common types of problems that you're going to run into. Bizarre, misleading error messages. And trying to figure out what the root cause of those error messages is the goal of the troubleshooting scenarios here. Here's one. User on their enterprise, on a particular enterprise server, whenever they started any MMC snap-in, they would get this dialog box right here. MMC will not run with a version of Internet Explorer earlier than Internet 5.5. And they're like, what? This is coming from a Server 2003 system that has obviously a newer version of IE on it than 5.5. So this is clearly a really screwy error message. Who knows coming from where? So they decided to take a Process Explorer trace of MMC launching. Let's go take a look at that. So there's lots of things in here. And this is where I want to show you the power of result analysis. So one of the quickest ways to go find a problem is to hone in on the most commonly problematic errors. And the most common problematic errors are access denieds. But not all access denieds are created equal. In fact, during normal operation, I've got Process Monitor here running normal operation, there are access denieds. One of the cool, quick ways you can see what types of errors or what type of any value is in a trace is to use this count occurrences down here. So I'm going to go down to result and say count And let's get an idea of the frequency of errors in a normal operation, a normal, perfectly healthy system. So success, obviously, is going to be the most common, but you can see these other ones, name not found. That's software that's going and looking at registry keys or values as part of a path search. Not necessarily fatal, not necessarily a problem, but could be. Reparse, which is hitting a symbolic link, a directory junction, which are common now in Windows, especially in Windows Vista and Windows 7. Fast I/O disallowed, which is basically just an I/O system saying you want to come the fast path. Nope, not open. Take the slow path. So that's not an error at all. File locked with only readers. That means that somebody's trying to open a file in a certain way with file locking that's not compatible. And you get the idea. Buffer overflow, that's not a security problem, though it looks like one. Buffer overflow means I'm passing you a buffer to read a registry key usually, registry value. It's not big enough, so I'm going to allocate a bigger buffer and give it back to you. Buffer overflow is really what would have happened if the thing had returned the data that you asked for because the buffer's too small. So let's see if there's any access denieds in here, actually. No access denieds in this trace. Normally there are access denieds. If I launched IE, for example, you'd see access denieds. Sharing violation, I want to highlight that one because that one is often the cause of unexplained error messages. That means that somebody's got a file open in a way that another application's not happy with, and they get a sharing violation. If they didn't expect that, that causes them to trip down an error path. But the number one most common error-causing problem, error that causes problems, is the access denied. So if I search through this for access denied, oh, this is my live trace, not that. Sorry, let me switch back to that capture. Access denied of that MMC startup, and I hit an access denied right here, which they went and looked at. It's a reg open key of HKey local machine, Microsoft, Internet Explorer, main feature control, and the result is access denied. So the question is, what is going on with that registry key? One of the ways that you can jump to a registry key, by the way, is to use this jump to thing, or a file. So you can click on that. It's not going to work too well on an access denied if your account doesn't have permissions, because it's going to try to navigate there, or the system account doesn't have permissions, because it's going to try to navigate to that place and not be able to. And that's the case here. This is running with full system rights. You can see right here. Where's the user? Oh, see, full system rights. No, I don't know what's causing that. It's running as the invisible man. Actually, this is from an older trace of Process Explorer. So we've updated it, and some of the data we've changed the format so some of the data to have richer information. So that's only there because this is such an old trace. But what happened? They went and checked the permissions, and the administrators group had no access to that registry key, something that they should have had by default. They looked at another system. So one of the things you always do when you get a permissions problem on some common key like that is go take a look at another system as reference to see what's going on there. And the difference was somehow, and again, this is really common such scenario, is who knows how that permission got stripped off that, but it was gone. And that was causing this bizarre error message. So they removed that, and the problem went away. This one I had sent to me just a couple months ago. This one user was using Internet Explorer 7, and they tried to use, on Vista, and they tried to save or edit one of their IE favorites, and they got this dialog right there. Cannot apply changes to this internet shortcut. Then they tried saving a new favorite, and they got this. And you can see that they're wise people trying to pick my blog as their favorite there. And they got that error message. I've recreated that scenario over here, so let's debug that one live. Fire up Process Monitor for live tracing. And go into IE and try to save my blog. Oops. Let's just go try to save sysinternals live. Add to favorites. And I get, oh, look at that. Unspecified error. That's my favorite error, by the way. It's better than unexpected error, isn't it? So what's going on there? Let's go, and one of the things, I've got so much stuff in here, I want to quickly drill down to just what IE is doing. How can I do that without having to scroll here, through here, and find IE? The way that I do that really quickly is to open the process tree by doing Control-T. This shows you the list of all the processes that were visible in the trace with their parent-child relationships. I go find the one of interest here. I say go to event, close, and then set a filter for that PID right here. And this is a really powerful feature, is just being able to quickly set filters just by right-clicking on the field of a line, and it automatically populates this include, exclude, highlight with the value of that field. And I'm going to select that for this 2072, and it's going to automatically apply a filter. So now I'm just looking at that process. And now let's search, because I know this is access denied. And there it is. Oh, that's a different one. Actually, that's not a real problem right there, even though it's an access denied on some registry key. Like I said, you would see these if you ran IE. What I'm looking for one is, well, there's a lot of them in here. There's one in a file. Oh, let's get rid of the registry stuff. So that was a class filter, which you're going to get up to here. If you just want to see file system or process-related or thread activity, you can use these quick filters up here. So I've just gotten rid of all of the, well, that's not, oh, here we go. So access denied, and the path is users mark Rust favorites, and it's trying to add a URL there. It's trying to just asking for write access. That's what that generic write is there, but getting back access denied. So why is it getting access denied? That was the question they had there. For that, they took a look at the permissions on that particular directory, and there seemed to be nothing wrong with it. Having been familiar, though, with the fact that protected mode IE takes advantage of Windows integrity levels, they suspected it might be an integrity level problem. Everybody here familiar with integrity levels? So IE runs at low integrity, so for it to be able to access something, it has to be ACLed with low integrity. And you can use a tool like Access Check from sysinternals to look for explicitly set integrities on a subdirectory, and that's what I'm doing here. And you're going to see lots of directories with low set on them, and they're all directories related to IE, so that IE can write stuff to them. Let's go take a look at that favorites directory, -D, so we're just looking at the root. And we can see that it's medium. So that means IE can't write there. This is what they ran into. They saw that somehow an integrity level was set on this incompatible with IE. Again, a mystery is how that got set. You can use a tool, iCackles, to set that integrity level back to low. And now let's go back and try that again. Save this. And we're just going to overwrite an existing one because that's already there. And it works. Problem solved. This one is a case of malware. Persistent executable is what I called it, because the first thing that happened that clued them in that they had malware is that there was an entry in the context menu on their C volumes. When they right-click on their C volume, that there was an autorun.inf present, autorun file in the root of the volume. So, and they also found that just opening volumes in Explorer the first time was always very slow. It always take 5 to 10 seconds. So they went and looked, because they suspected of that autorun there. They went and took a look at that autorun, and you can see that, first of all, it was hidden, and it was read-only there on the left. They looked at the contents of it, and they saw references to something opening some executable with a bizarre name. They went and deleted those executables, and they would reappear. So they decided to see what was recreating those files when they just deleted them, and they pulled out Process Monitor and captured a trace. Let's go take a look at that. Oh, you know what? I need to run the 32-bit one to open that trace. It's nice to hear the session from the other side, isn't it? So if you're kind of bored with this one, you can listen to that one over there. Persistent executable. This is what they saw, a whole bunch of accesses. When they deleted any of those files, they saw this burst of activity coming from Explorer. Reading, writing, files. And so what is creating this file right here? So here's a query open on that file. For that, they turn to the stack. And this is what I was mentioning earlier, that you know what, that's not a good trace there. That is actually Explorer itself responding to the creation of that. You know what we're going to do is set a filter so I can find the right one, which is a category filter of only writes, because we know that whatever is doing this is writing. Explorer is probably just reading in response to that thing appearing, and there we go. So we got a whole bunch of writes. Now the stack for these should give us the answer. So filter manager, if you use process monitor at all, you're going to see this on all file system traces, because this is the file system filter manager that process monitor plugs into, its driver plugs into, so it's going to be present in all of them. The kernel, obviously, is next, and then there's this DLL right here. What the heck is this? If you look at where it's located, it's in the system32 directory. So they went and took a look at that file. Actually, they went to look at what was causing that file to get loaded into Explorer first. Well, they deleted it, but then what's causing that file to get it loaded in Explorer? For that, they turned to autoruns. How many people use autoruns instead of msconfig? How many people use msconfig? Anybody? Yeah, you should be ashamed of yourself. msconfig is like walking into a dark room with both hands tied behind your back. That's the way that I call it, because msconfig just doesn't show you a whole lot. Let's take a quick tour of autoruns on my system here. By default, it's going to show you every single extension and plugin that can gain software automatic execution when the system boots, when you log on, when you launch IE, when you launch Explorer, or when you play some media. All of those things are common places where malware lurks, also common places where third-party software lurks that could be screwing up your experience. It shows you on this Everything tab the whole list. It also divides them into categories here, so you can look at individual types of extensions. The full list, though, on a typical system like mine, is just enormous. So weeding out the stuff that's really part of the system, or the stuff that you trust from the stuff that isn't part of the system, which might be causing you problems, is made possible with these options up here that let you set filters. Hide Microsoft and Windows entries, or just hide Windows entries. I always run it with hide Microsoft and Windows entries because I kind of trust Microsoft now. So I just do a refresh there, and I see all the third-party stuff. And I left this for you. I've had this system installed for about a week, and I've just installed the standard things that I use. And I haven't done my normal cleanup activity, so you can see the kind of junk that I always get rid of. Yeah, so look at this one. This is what really kills me. Speed launcher. Yeah, it speeds. This is like so selfish of these guys, and anybody that sticks them in there, because it speeds them up, but slows everything else down. So they're like making themselves look good at the expense of everybody else, is the way that I view it. And by the way, there's nothing more annoying than these two guys, because every time you get an update from Apple, it sticks these things back, which is really annoying. So I've just configured a task that runs twice a day to go and clean that for me. So what they did is they first, so that was an introduction to autoruns. Let's get to how this guy used autoruns. He had to figure out, well, what processes was that thing loaded into, because that activity was coming from Explorer. Malware, most often now, injects itself into a whole bunch of processes as part of its resiliency system. In fact, you could kind of look at it as like the malware authors are the cutting edge of reliable software. The redundant, reliable, super strong. So what if we crash, we come back even better and stronger? And that's the case with this guy. So he did a Process Explorer search for that DLL. Process Explorer searching, most of you have probably done it, but for those of you that haven't, let me just show you how useful this can be, demonstrating a bug that I've just submitted that's been there forever, but I just ran into it just the other day, and I'd forgotten about it. And so because of the time difference between I caused an action and I ran into the problem, that I didn't realize what it was, and I used Process Explorer myself to rediscover this bug, which I then promptly resubmitted to the Office team. Dave sent me an email today. This is one of the new cases. This is he mentioned that in his class, this Realtek driver hang. There's the dump for it. And so what I did was save it to a file. So I'm going to create a file, a directory. We're going to put that thing in. So I'll call it hang, and then let's go do a save as into C:hang. And then let's just go ahead and, at that point, try to delete that directory. Yeah, I'm sure. And look what I get. The process cannot access the file because it's being used by another process. This is exactly what I ran into. I'm like, what the heck? There's nothing open nothing that should be using that directory. So I came up in the Process Explorer. I did a search for C:hang. And there it is, Outlook. Keeps a handle open to the last directory that you do a save as into. Believe it or not. So you can double click and go right to that handle, and then you can, without having to exit Outlook, you can do this. Close handle. Yeah. There. So I've just pulled the handle out from underneath it, which actually I don't recommend you do. But it's kind of fun. And the problem goes away. So in this case, he did a search. He found this DLL loaded in a bunch of things because that search not only searches for handles, but also for DLLs. He found that amv0.exe, found it on auto runs, and removed it, deleted it from the system run key using auto runs. Problem solved. Malware cleaned. Let's talk about application crashes now. And application crashes, one of the reasons I used to never even talk about this in my troubleshooting cases is that most of the time an application crashes and it's like, okay, that application crashed. Not much you can do about it. But then over time I started to realize there are some things you could potentially do about it. First of all, monitoring what happens with Process Monitor before the crash might give you clues. What if it runs into an access denied right before the crash on a registry key? I've seen that before. Also, lots of processes pull in junk, third-party junk into them. Not just the common ones of Explorer and IE that IE loads of browser helper objects and ActiveOS controls, but any process might be loading keyboard hooks into it and other software that you've got on your machine that just wants to be in every process to do something cool for you. So the crash might not be the cause of the process you think it is, that host executable. It might be the cause of something inside of it. And so that's where application crash analysis comes in. So what you have to do is, first of all, find the crash dump file. That was a little bit easier on older versions of Windows, on pre-Vista systems, because you get that "We're sorry" dialog box. So you can see down there it says "We are sorry." And then you would say, click here for more information. You get this, and then say, click here for technical information. So this stuff isn't really technical, I guess. And then you get the path to the dump file, and that's what you're going to go open. On newer systems, there's a couple things you can do to troubleshoot or to find a dump. One is to actually attach with the debugger to the dying process before it's gone away, because those things hang around when you get one of those dialog boxes there, like this. So because by default, when something crashes on newer versions of Windows, Tox, Tools, Stack Trash, this is a program I wrote. Dave's old program that he wrote that I normally use here, Acvio, for some reason doesn't work anymore. So even Dave can't write a buggy program that's reliably buggy, I guess. So I had to write one, Stack Trash, and when I click that, it's actually going to fault, and it's going to hang around. So what I can do when I get a crash like that, if I canceled that, or I'm going to get this dialog box that offers to close the process. If I closed, the dump is going to be gone because it's going to send up to Microsoft and then get deleted off the hard disk. So what I'm going to do is launch WinDbg and attach to it. I'm just going to do this to show you. There's nothing, no third-party things. Attached to process, and then I do, where's Stack Trash? There it is. Stack Trash, and that's what you would do. And then I'm going to show you the steps that you would do following that in a second. But that's how to attach to a dying process where you might not have a dump on newer versions of Windows. One of the things that I always do, though, on a Windows system when I get it, is to Oh, actually, let me stop here, because there's cases when you get a crash like that, and IE is the most common, because you know IE now creates multiple processes with IE8. So the question is, which of those ended up crashing when you do get a crash? Or if you've got multiple processes, which one is the one that's the problem? For that, you can go take a look at this where fault, Windows Error Fault Reporting process, which is the one that actually shows you that dialog, and one of its command line options is the process ID of the process that it's reporting the crash for. So that's the way to uniquely identify, if you've got multiple processes running, which one is the one that you're interested in. But one of the things that I always do when I configure a Windows system is to have Vista or Server 2008 or newer versions of Windows always save a dump for me of any crash. And you do that with creating that registry key right there, and it will always save the dump to a particular folder, the local app data crash dumps directory. If it's a crash in a system process, then you need to go look in the system the system accounts profile and its crash dumps directory. You can, if you don't want this thing consuming all your disk as the thing fills up with crashes, you can limit that with some registry values. So now we're ready to analyze the crash dump. And those of you that saw the crash dump analysis session from Dave and Dan, you're going to be familiar with this. It's basically take a look at the dump, look at the stack. That's the number one resource for figuring out what's going on. Scroll through the stack for the current thread, and then pick every thread in that process looking for ones that have a function name in it that says fault, exception, or error. And that is the thread out of all the threads in the process that's responsible for actually triggering the crash. When you connect with the debugger, you're actually going to be sitting inside of the debugger's thread. So this is very important to go look at every thread in the process like this. Open up the debugger and go to View, Processes and Threads, and you can see that there's 3 threads here. If we look at the stack by opening the stack window here, this is the debugger's thread. So we're going to need to go look at these other threads. And of course, this is the 64-bit debugger debugging a 32-bit process, so we're going to see garbage here. But that would show up as stacktrash.exe in a real-world situation. So what you might see there on one of the stacks in the faulting thread is the name of a third-party extension. Check for a new version, obviously. Uninstall it if the problem persists, or just delete the mechanism by which it got into that process using autoruns. So here's a real-world case. A user Explorer would randomly crash when they right-clicked on a file in Explorer. Didn't happen consistently, just some of the times. So they attached to the dying process and analyzed it. This is one that somebody sent in to me. This is a pretty cool one. Let's go into WinDebug. Cancel out of this and open that dump file and see what they saw. They did a K command to look at the stack, and this is what they saw. Again, work your way through this looking for third-party components. User 30, and this is going to just take some experience to figure out what's part of the system and what's not. User 32 is part of the system. NTDLL is part of the system. Anybody see something that's not part of the system? And oh, by the way, there's that telltale sign that this is the thread that's caused the problem. But, what could it be? How about this? Unloaded muang-sys.dll. Now, obviously, this DLL really isn't called unloaded whatever. This is WinDebug's helpful way of telling you that there used to be something loaded in the process at that point, which was called muang-sys.dll. It's not loaded there anymore. Normally, you'd be able to go try to find more information about it using the lm command, the list module command, but that won't work for a module that's not even loaded anymore. So the user had to figure out, what is this thing coming from? Because they didn't recognize it. So they ran Process Explorer. They looked at the path to that DLL. Well, look, no version information, another telltale sign of malware. They looked at the path sitting in the Windows System 32 directory, another telltale sign of malware. So then they're getting very concerned. So they used strings, the strings utility, to look inside the executable. And if you run strings on something, it's just the same thing that the Strings tab in Process Explorer would show. It just shows you data, raw data, printable characters from inside of this image file that might have useful information. Now, we're looking at a kernel32.dll. There wasn't anything useful other than up here you saw references, well, it's already scrolled off, to some of the things that it's importing. So the way to peer inside and maybe look for hints, which is what this particular user went for, I don't have Zoom it here on the presenting machine, but if you look through that text that they spit out from strings, this is part of an application manifest embedded in the executable, and the description of the product is right there in the string. So even though they didn't have it in the version resource, they did put it in the manifest, and it's there, Microangelo by Inkpack Software, and that rang the bell. They'd been using this icon editing software from this company. They relied on it, so they couldn't uninstall it. They went to the vendor's website, no newer version, so now it's time for workaround. So they opened up auto runs, and they disabled the shell extension by just unchecking it. So one of the golden rules of troubleshooting is never cause permanent changes if you can avoid it. Always make sure that you can get back to where you were, because if you, for example, deleted this, and the process of deleting it would cause Explorer to just, here, let me troubleshoot my pants here, would cause Explorer to always crash, then he'd want to put that thing back and figure out some other way to deal with this. This especially applies to registry keys or files. Rename them. Don't delete them, because you might be sorry. So he unchecked it, and the problem went away. Let's conclude now with a quick look at crashes and hangs. I'm just going to be talking about crashes. So this is kernel mode crash analysis. And again, the goal of kernel mode crash analysis, you know that the system crashed. The question is, what caused it to crash? Because the system is a giant host with lots of drivers hosted inside of it. And any one of those drivers could be the problem. I was going to have the case of the crashing phone call, but Dave stole that without telling me in his session. So I had to, at the last minute, just reach into my deck and pull out one of the many other cases that I could show you. This one, my daughter ran into. I'll explain that in a second. But you might be familiar with the online crash analysis. This is the, hey, do you want to send this into Microsoft? Or now it just does it automatically and will tell you at some point, hey, you've got a problem resolution. You've got a new driver to download. That is useful in many cases because Microsoft's doing automated analysis. We've got engineers that are actually looking at these dumps and figuring out what's going on, and then contacting vendors and working with them to get resolutions like this particular one you're looking at here. But many times you won't find a resolution for a crash that you happen to run into, and then you need to dig in yourself. So first of all, get the tools ready. You need the debugger, WinDebug from the debugging tools, the same one we just used for the application analysis. And you need the dump file, just like we needed the user mode dump file. We need the kernel mode dump file. There's all sorts of rules about whether it's in the mini dump directory or whether it's in the system directory, depending on which version of Windows you're on, whether it's professional or server. You don't have to remember any of that. The rule is just go look in the Windows directory. If there's a memory.dump file in there, that's the one you want. If there's not, look in the mini dump directory and find the most recent mini dump, and that's the one you want. No having to remember weird rules. So this one, my daughter was experiencing intermittent crashes. And having read Windows internals to her at night over the last, she's only 9, I was really disappointed that she didn't figure this one out on her own. So I took away TV for a few days, made her read that chapter again, and then went and I helped her walk through this one so she could learn. So we opened the dump file. Let's go open that dump file. And it's this one right here. And again, it's going to be trying to pull out symbols for things that it doesn't have symbols for. And what this is going to do is do a basic analysis where it might point the finger at a particular driver. One of the things that I always do, you see that hyperlink bang analyze -v? Once I get a prompt that I can interact with, I'm going to click on that hyperlink, which is what I always do. Number one rule in crash dump analysis, always click on that link because it will automatically spit out more information for you so that you can, for example, see the crash code, which might give you some information. This is the most common one, equal, not less or equal. And then you look at the stack. And again, the rule is find third-party stuff. And this takes some, just like I said, getting used to. So there's AFD, which is part of Windows. And one of the giveaways that these things are part of the system is the fact that there's symbol information, that you're seeing function names here and not just raw offsets. So immediately I see, oh, there's a third-party thing, there's a third-party thing, there's a third-party thing, and so on. Now this particular one, near the site of the crash, though, closer to the site of the crash, we see this. So this is most likely the cause. So this is the first source of investigation, the first suspect that we've got on our list. So what I do is do an lmkvm command that you can see there from inside the debugger. Shows nothing useful. Sometimes this will have version information loaded into it. If it's still in the RAM of the computer, you will see it. If it's been paged out, then you won't see it. Most of the time, it's been paged out because this isn't obviously useful use of your RAM to be storing version information. So what I had to do is go find the file on disk. I used a tool called SIGCheck to look at the version information. I'm more command line oriented. So using SIGCheck, I can, for example, look at the version information for NTFS, and it will tell me if it's signed, and if it will tell me when it was signed. So this gives me a date of when it was actually published, and who published it, and what it is, and what its version, and so on. For that driver, I went and looked at the version. You can see the version number is 6.1837. So I went to the Realtek site. So I wanted to see if Realtek actually had a newer version. That's why I looked at the existing one to see if I was even wasting my time by going to their site. Sure enough, they had a new one. Looked like they had a new one. I downloaded it, verified that it was newer, not just, here's the older one that you want that still has the problem, but here's a newer one that might have the fix. It was 6.195. Definitely newer. Updated the driver, resolved the crashes. Never, haven't had the problem again. Unfortunately, I wanted to test Maria, so I've actually put on myfault.sys and exercised her a little bit more that way. She's doing pretty good. All right, there's the crashed phone call that I got rid of, that I'm skipping because Dave covered it earlier. And that brings us to the conclusion. So, whirlwind tour of troubleshooting. A bunch of tools that I've covered: Process Explorer, Process Monitor. I've shown you some features maybe I hope you were aware of, but I hope you also learned something here about them. The summaries, the way to look at the errors, some tips on how to find errors of relevance, shown you real-world cases, and also covered, of course, some application crash dump analysis so that you can go find third-party culprits for crashes, kernel mode crash dump analysis so you can quickly get to a cause of a driver crash. You saw that in both those cases, I basically had to know nothing except for debugging tools, symbol engine, and just open where the dump file was, and I was able to find out the cause. So with just a few minutes and some basic knowledge, you can end up troubleshooting and solving, or, like I said, finding the workaround for lots of different problems. So thank you very much for coming. Remember to check out the 2 previous case ofs. Like I said, all different cases and different techniques posted on my webcast page at SysInternals.